In this last video, I'm just going to review some z-score logic and then go over a couple more practice problems with you. So as a review, when we're talking about z-score distributions, when we change the labels of our x-axis to reflect z-scores as opposed to raw scores, the shape of our scores doesn't change. The mean or the mu is transformed to a value of 0, and the standard deviation is transformed into a value of 1. So you might want to write all this down. For a z-score distribution, when we standardize a distribution, these three rules take effect. And we do this because it's easy to then compare across distributions. So I can take different types of tests that maybe people take and compare their performance relative to their own particular groups. So here's the first one. Juan received a score of 65 on his math exam and a score of 85 on his reading comprehension exam. So the math exam had a mean of 60 and a standard deviation of 3, and the reading exam had a mean of 80 and a standard deviation of 5. So we want to know on which exam did he perform the best. So let's take a look. Let's work this out. We'll start with the information over here. We have for the math score a mean of 60, standard deviation of 3, but Juan's score was 65. And for reading a mean of 80, standard deviation of 5, and Juan's score was 85. So what we're going to do first is find the z-score for math for Juan. So it equals the score of 65 minus the mean of 60 divided by the standard deviation of 3. So 65 minus 60 is 5 over 3, which gives us a z-score of 1.67. All right, that's one z-score down. Let's take a look at the other. We'll take Juan's score of 85, subtract the mean of 80, and divide it by 5. And so we have 85 minus 80, which gives us 5. 5 divided by 5 is 1. So Juan's z-score is a positive 1. 1 standard deviation above the class average. Okay, so you can readily see right here that Juan did better on the math test than the reading test. But I'm going to draw this out. Let's take a look. Put up a normal distribution first. I'm going to put the mean of 0. I have a standard deviation of 1 and a standard deviation of 2, and also a negative 1 and a negative 2. So Juan's math z-score was 1.67. So it's somewhere between 1 and 2, sort of about there. This is going to be the math score for Juan. And Juan's reading score here was 1. Very good. So when we're looking at positive z-scores and we're looking for a high z-score, we look for the score that's furthest away from the mean. And in this case, 1.67 is farther from the mean than 1. It's a more extreme score. It's a more unusual score. It's a higher score. Let's take a look at our next one. Here's our second one. Jessie received a score of 69 on her math exam and a score of 77 on her reading comprehension exam. The math exam had a mean of 75 and a standard deviation of 4, and the reading exam had a mean of 80 and a standard deviation of 6. Again, same question. On which exam did she perform best? Let's work this one out. So here are Jessie's scores, and for math, the mean was 75, the standard deviation is 4 for the whole distribution, and Jessie's score was 69 in math. In reading, the mean was 80, standard deviation was 6, and Jessie's score was 77. So let's start by finding the z-score for both math and reading, and then we can compare them. So we're going to take the score of 69 minus the mean of 75. We're going to divide it by 4. So that gives us 69 minus 75 is negative 6 divided by 4 equals a negative 1.50. Let's do Jessie's reading score. We have her score of 77 minus 80 divided by the standard deviation of 6. 77 minus 80 is negative 3 divided by 6 gives us a z-score of negative 0.50. So we had negative 0.50 for reading and a negative 1.50 for math. So let's draw this out to see on which test Jessie did better. I have my normal distribution. Put a 0 in the middle, and 1 standard deviation, and 2, and minus 1, and minus 2. All right, so the math score is a negative 1.5, so it's right in the middle of 1 and 2. Put an M here for math. The reading score is a negative 0.5, so right there for reading. All right, so clearly Jessie did better in reading than in math. And when we're dealing with negative numbers, we look for the score that's closer to the mean. So in this case, her reading score is closer to the mean, it's the higher score. So with a positive score, we were looking for scores that were farthest away from the mean in terms of which one is better. But with a negative score, we're looking for scores that are closer to the mean. And in this case, reading is the area that Jessie did better in. For this next one, we're actually not going to do any calculations. This is a critical thinking question, so we don't need to do any math with this. Jordan received a 35 on a test. If the class average was 40, what do we know about Jordan's z-score? If you need to pause the computer, do that. Well, Jordan's z-score is negative or below the mean. That's what we know. Jordan's score is less than the mean, so the z-score by its very nature has to be negative. Leslie received a 79 on a test, and let's just say her z-score is 0. What do we know about the class average then? What is the class average score? Pause the computer if you need to. The class average was 79. If Leslie was right on at 79 and her z-score is 0, well, that means average. So that means the class average was 79. For this last one, we're going to think about it. It's a lot of critical thinking here. George received a 20 in a quiz, which gives him a z-score of plus 0.5. What was the class average if the standard deviation is 2? So we don't know the class mean, in other words. But we do know that George has a z-score of 0.50, and the standard deviation is 2. So a z-score of 1 is going to equal a standard deviation of 2, or it means 2 points. George has a z-score of half of that. He has 0.5. So he is 1 point above the mean, which means that the class average is 19. If you didn't get that, think about it a little bit. Okay, these are all the things that we're talking about this week in terms of z-scores. And next, we're going to dive into probability. It's really exciting. I'll see you there.